Today I'm going to present my interactive visualization tool for exploring road safety data in Great Britain. This tool was developed for the JBI100 Visualizations course resit, and it's designed to provide users with valuable insights into accident patterns and trends. Upon landing on the page, you'll see the interactive map on the left, which displays the geographical distribution of road accidents across Great Britain. You can zoom in and out, pan around the map, and hover over individual data points to view additional details such as the date, time, sex, and age of the driver, severity of the accident, age and type of the vehicle, and light conditions. In the center column of the page, you'll find a range of settings that allow you to filter the displayed data. As we adjust the filters, the plots dynamically update to reflect our selections. This interactive feature allows you to explore the data in real time and gain insights into how different factors influence road accidents. You can select a specific date range using a slider, choose the time interval of the day, and filter by driver age, vehicle age, light conditions, accident severity, and gender of the driver. Next to the filters, on the right side, we can see a series of plots that provide additional visualizations of our data.
First, the stacked bar chart displays the distribution of accident severity by driver gender, comparing the proportions of fatal, serious, and slight accidents for male, female, and drivers with the unknown gender. Note that the colors used in the stacked bar chart, as well as the map, are chosen to be distinguishable by people with various types of color blindness, such as red-green or blue-yellow color blindness. Next, we have a histogram paired with a kernel density curve that visualizes the distribution of the age of the drivers involved in the selected accidents. The histogram shows the frequency of accidents for every age, and the kernel density curve provides a smooth approximation of the age distribution. Similarly, we have a histogram showing the distribution of the age of the vehicles involved in accidents. This plot helps us understand if certain vehicle age groups are more prone to accidents. Lastly, we have a heat map that visualizes the relationship between the first point of impact on a vehicle in an accident and the severity of the accidents. The heat map uses a color gradient to represent the relative frequency of accidents for each combination of impact point and severity level. Darker colors indicate a lower frequency of accidents, while lighter colors represent higher frequencies. We can also hover over each cell on the heat map to learn the exact percentage of a given accident severity for a point of impact in accidents. To demonstrate an application of the tool, let's consider a scenario where we want to investigate the difference in accident severities between rural and urban areas during the winter months. First, we'll use the date range selector to select November and December. Next, we select an area in the inner part of London, which is a densely populated urban region. Looking at the stacked bar chart, we find that for male drivers in London, accidents are severe in 8.5% of cases and fatal in 1.8% of cases. For female drivers, the proportions are slightly lower, with 7% of accidents being serious and 0.85% being fatal. The age distribution histogram shows that the majority of drivers involved in these accidents are between 20 and 50 years old. The vehicle age histogram indicates that most of the vehicles involved are not older than 15 years. The heat map reveals that the most dangerous point of impact in London is the front, with 9.72% of frontal accidents resulting in severe outcomes and 2.85% being fatal. Now let's compare these findings with a rural area. We can use the map to select an arbitrary rural region and analyze the updated visualizations. In the rural area, we observe an increase in the severity of accidents compared to urban London. For male drivers, 4.75% of accidents are fatal and almost 20% are serious. For female drivers, 1.7% of accidents are fatal and 12.5% are serious. The age distribution of drivers and the age distribution of vehicles involved in accidents remain similar. However, when we examine the heat map, we notice a significant difference. In rural areas, accidents involving the near side, back, and front of the vehicle tend to be much more serious compared to urban areas. Additionally, accidents with no impact also show a higher severity level in rural regions.